So welcome back. If you saw my last video on the product rule, this one will be on the raising a power to a power rule, which is rule 2, kind of in the exponent unit. Now, I should qualify that just for those of you who take algebra or just trying to gain a better handle on this stuff. There is multiple rules, and it's arbitrarily naming it rule 2, but it's just a second rule. It could be the third rule, whichever. It doesn't matter. These are just rules that you need to understand how they work. Looking at the rule, it says a to the m power. Then outside of the parentheses, we have this another exponent n, so it's a to the m power raised to the n power, and that will equal. The rule tells us that we can multiply these two, which makes kind of sense if you remember the distributive property from way back when. So let's look at the rule. So it helps us understand it because we can think about this exponent outside the parenthesis being applied to this, saying that it's repeated multiplication. So that means we should have 3 of these groups, 2 to the 4th power. Right? So if you have those 3 groups, then again, it's repeated multiplication. So I'd have 4 2's and then 4 2's and then 4 2's for a total of 12 2's. Now, I'm not writing everything out completely here, but this is just kind of a good introduction to the concept with some examples that should guide you. So I have the expanded form, and what we can then say, right, is that we could have just multiplied these two together, and that would have gotten us to the same thing. So we don't have to do this expanded form every time. It's a lot of extra labor. That the goal is not to be labor intensive in mathematics. It's to unravel ideas. So if we apply the rule here, we get x to the 3 times 4, which is x to the 12th. So really easy when we just have these one variables or this one numerical expression. But what happens when we start adding things to it? Oh, and there's no exponent on here, but we will add one just for the idea. So we'll put a 3 there. It doesn't matter what it is. It's conceptual. So again, I do want to distribute, just like we talked about. So I want to distribute this 3 to the 2. That's an exponent, and I want to distribute the 3 to the denominator that has a 2 as an exponent. But what about this 4 and this y? So 4 by itself is just 4. So 4 to what power is 4? Well, a 1, right? Because 4 to the second power would be 16, so 4 by itself must be a 1 as the exponent, and so y by itself must have a 1 as an exponent. We don't write the 1 because it's just by itself, but it's important that we know it's there, so I'm just putting it there visually so you see it, but you don't need to. If you understand that, you don't need to add it. So we would distribute, again, parentheses with a number outside of it tends to want it be distributed, and we distribute it to all the exponents inside the parentheses, just like we would distribute something outside the parentheses to everything inside the parentheses from earlier in lessons. So we end up with 4 to the 3rd, x to the 6th, y to the 3rd over z to the 6th. And it makes sense. 3 times 1 is 3, 3 times 2 is 6, 3 times 1 is 3, 3 times 2 is 6, right? Now, it is best practice to, if you see a number that's got, it's a small number with not a very major exponent, just to simplify that, and 4 times 4 times 4, it's just 64. And you can always check it with a calculator. But the calculation mistakes can happen, but you go back, you work through them. Procedurally, though, if you understand the procedure, those calculation errors minimize. Calculation errors just disappear in general the more you practice correct procedure. So we can apply that same logic of adding a 1 to everything down here that doesn't have an exponent, and then we apply this distribution to every exponent below, right? And so what do I end up with? Now, this is a little tricky. I have this -2 here, and I'm going to do 4 times 1, so it's going to get the 4th power. But because this is in parentheses, I really should just keep this in parentheses because I want to understand that the negative sign is getting the exponent as well. So the -2 is part of that. So then I have h to the 1 times 4, which is 4th power, g to the 12th power, because 3 times 4, over 3 to the 4th power, because 1 times 4, and then over m to the 24th power. Now, we can simplify the numerator and the denominator coefficient, and they simplify, -2 to the 4th power is just 2 times 2 times 2 times hopefully I got 4 2s there. 2 times 2 times 2 times 2, or negative 2 times negative 2 times negative 2 times negative 2, which is 16. And then we have still h to the 4th, g to the 12th, and then over 3 to the 4th, which is just the same thing as like 9 times 9, which is 81. You can verify that, but this is just the simplified form, and that is the raising the power to a power rule. Thank you.